the EMC Video On Demand Library.
Hi there, my name is Chad Sakach, and part of this ongoing TCP/IP and iSCSI discussion is going to take a turn for the more technical here. We're going to be talking about virtual LANs, or VLANs. Now, while I said it's going to get more technical, VLANs are very simple in their core concept. It's important for us to understand as we're communicating to customers because VLANs are an important part of iSCSI design. Perhaps most importantly from a sales standpoint, VLANs will be used against you by our competitors claiming that we don't support VLANs, that we don't support VLANs the right way, and it's important to be able to address that customer concern or that objection right up front, because the reality is we do support VLANs. Both types of VLANs is what we're going to discuss here. So what are VLANs? VLANs are the idea of a virtual LAN, being able to partition in a way that's very similar to fiber channel, be able to partition switches into virtual switches. Let's look at a first example called port-based VLANs. And let's look at a practical example to try and make this real. Let's say that we have an Exchange server and it has two network cards. Now, these are plugged in to an existing Ethernet switch that has 3 ports, bang, bang, and then there's an iSCSI storage array, let's call it a Solera or a Clarion, plugged into this port here. Now, this is the public network interface, and the customer then installs the Microsoft Software iSCSI Initiator right on top of this, turning this into an iSCSI network. But this switch is only one switch, right? Shouldn't the customer have 2 switches, one for iSCSI and one for their public network, which is indeed a best practice? Well, the reality is that you can create what's called a port-based VLAN to split this switch in half, where you basically say this port here is part of VLAN number 1, and this is part of VLAN number 2, and this is also a member of VLAN number 2. What this means is that logically, this is the same thing as drawing it like this, where it's plugged in into the LAN via one network card, and the other network card goes into an iSCSI SAN connected to that NS or Clarion. In other words, you've split that switch, creating 2 logical switches, one here and one here. This one is part of VLAN 1. This is part of VLAN number 2. In other words, port-based VLANs are an easy way to create an iSCSI network that is logically separate from your public LAN. Now, a port-based VLAN will work with any device because, as you can see here, the idea of the VLAN only exists within the switch itself. In other words, these network cards don't have any idea that they're part of VLAN 1 or 2. The switch is just going, hey, only allow traffic to go between these ports, not between this port and one of these other ones. Now, the other example, so let's draw a big line here, and I'll draw it in a different color to reinforce this. The other example is something called VLAN tagging. Sometimes, confusingly, these are called VLAN trunks. Now, VLAN tagging is very different than port-based VLAN. So let's come back to a similar example. We've got our Exchange server, and it has a network card, and it's got another network card, and it's connected to an Ethernet switch. Let's stick in another host here. We'll call this, whatever additional host that's required. And it's got a NIC also. And then we've got an array target. Now, in this case, I'm going to choose to make this a Solera example because it is pertinent and unique and different. Now, in this case, what a VLAN tagging does is that as these are plugged in like so, the Solera will basically send Ethernet frames down this wire saying, hey, this Ethernet frame belongs to VLAN number 1. Oh, but this next one is different. It belongs to VLAN number 2, right? And what happens is the Ethernet switch inspects or looks at the header or the front of every Ethernet frame and says, aha, this port here is a member of both 1 and 2. So I need to look at and be careful about what the data is that's coming across the wire. Now, this one here is a member of 2 only, and that's a port-based VLAN because this is using iSCSI via the software initiator, same as in our previous example. This one here is the LAN, which is number 1, and this one here is also a member of number 1 because it's a host and it's connected to the public LAN. Now, you could take that in an analogous way, draw that very similarly, where you'd have your LAN and your Exchange server was plugged into it. You'd have the host up here in our example. This is the Exchange server, and it's connected down to the iSCSI SAN 2 or Solera in the example, right? But the Solera is also directly plugged into the LAN because that port is a member of 1 and 2. Now, why is this important? The reason it's important is that a storage target that supports both iSCSI and NAS may need to have ports that are connected to both the iSCSI VLAN and the public LAN. And you need to basically then have VLAN tagging. And we'll bring it back and compare it with port-based VLANs in a second. Now, VLAN trunks are the idea of if this switch was connected to another switch and you wanted to maintain those VLAN tags, you'd establish a VLAN trunk between these switches. Again, this is a more sophisticated concept, but to bring it back and say, why is this important for you as a rep? The reason it's important as a rep is that storage vendors have chosen to implement one of these 2 ways of doing it. For iSCSI support and to be able to say to a customer, look, you can leverage your existing investments in your Ethernet switches, but create separate iSCSI networks, all you need are port-based VLANs. And this is how most iSCSI-only targets, or iSCSI and fiber targets, in other words, pure block-based devices like the Clarion, work. In other words, a Clarion supports port-based VLANs. Now, devices, on the other hand, that are examples that are NAS devices that also do iSCSI, examples are the Solera, Network Appliance FAS platforms, support both port-based VLANs because, as we've discussed, any Ethernet device supports a port-based VLAN. But they also support this idea of VLAN tagging, and that's critical when you support both iSCSI and NAS. To wrap this up, these are 2 different ideas that solve the same problem. How do you leverage your existing infrastructure to create separate, logically isolated Ethernet networks? The key point is that we can solve the customer challenge regardless of the 2 ways that they want to do it. It's no competitive disadvantage to EqualLogic, Network Appliance, or any of the other IP storage vendors. Thanks very much, and I hope that this has made VLANs more clear.
The EMC Video On Demand Library. Sharpen your competitive edge in minutes.